So I tried to solve it in a clever way by doing breadth first search and by doing optimizations, by trying to be smart basically. That did not bring me anything but frustration, so maybe ignorance is bliss. And as I see many people solve the second part of day 10, city solvers like that 3, and today I woke up and chose that 3. Let's use that 3 to solve this. So let's go back to day 10 and let's do it in Python now. Yeah, I'm getting really distracted by the sounds, but yeah. So one is string int. Oh yeah, that must be 2. Cannot type to do. And example txt, read text, the same for input. Why did I jump to the end? Yeah. Let's assert that solve2 of example is what? 33. And let's print solve2 of input as well. But maybe not now. Yeah, and let's open that in that. Okay. Oh, actually, I can fix it like... yeah. First of all, I need to reparse it in Python, because why not? Parsing should be easy. For each line, split lines, I say that words are line split. Then I take the first word. Oh, actually, I can ignore it for this task. So I only need to take the last word for the joltages. So Rust, I'm writing Rust again. Joltages are yes. Then I have to take the last word. -1. And I have to remove a prefix like this. Why is it F? Remove suffix like this. I can also split it by comma. So basically joltages become a list of int v w for I'm out of letters in this one. Let's just make it slightly more balanced. Yeah, so joltages become this, and masks become for word in words starting from 1 and excluding the last one. Again, remove prefix this and remove suffix this. Then again split import split by comma, and that produces the list of numbers here, but is that actually what I want? Maybe, I don't know. Let's see later. Ask. That should conclude the parsing, right? Why do I do this? And let's have some debug output. Joltages and masks. What's on? Possibly unbound value. Right. And here import sys. Good. Now what do I do? Let's verify that it parses. Yeah, the first case is like this, the second is like this, and the last one is like this. Okay. Now I need to figure out how to use that 3. Yeah, that. Wait. That's a little bit weird. Okay. I don't know why it puts its own executable in the path, but whatever. What do I have to do? For each machine, I have to find the smallest number of presses that gets it to 0. So let me just down quickly. Let's look at the first example here. Sample 0. What does that mean actually? That actually means the following thing. There is some amount of presses. This is like a system of equations, and the first equation is 3 is equal to number of presses 0 multiplied by a0 0 plus n1 by and so on and so on. So basically this is number of presses 0. Let's expand this a little bit. This goes away and this becomes like this. So I do have to convert it to binary masks. It's much easier to work with it in that form. Okay, 1 0 1, and this becomes 0 0 1. Yeah, 0. This becomes 0 0 1 1. This becomes 1 0 0. This becomes 1 means mask is like this. Okay, so now we have these masks. Let's call it mask 0. And mask 5. If I want to know how do I get to 3, I have to press n0 times mask 0, 0 plus n1 times by mask 1, 0 plus n2 by mask 2, 0 plus n3 by mask 3, 0. The same goes for all the other. That is voltage 0. That's a good idea to make it like this. And here again comes like this and like this. And here it becomes and so yeah. What we don't know is, in this example, we know that n0 should be 1, and 1 should be 3, and 2 should be... Wait. Unfortunately, I need more masks. And 4 by M4 plus and 5 by M5. Let's say 0. Yeah, something like this. And we know that the solution looks like 3 times. This is pressed 0 times. This is pressed 3 times. 0 to once. 1 and 5 twice. The result is sum of n y. Minimal number of presses to get to voltages. The minimal, because the sets of presses can be different, but they all have one minimal sum. Nice. Okay. What is the fewer amount of presses? Okay. Input. I, J, J. Output. Argmin, sum, E. N, I. Where N, I should be between 0 and whatever. Okay, how do I use that 3? That's 3. Let's start with the following simple example. Okay. Solve that option. Basic mathematical operations, creates real variable. How do you ask questions solvers? Yes. So I can check the Boolean proposition. That's not what I want. arithmetics. And what do I want here? I can introduce variables. How do I ask questions or minimizing something? Machine arithmetics. No, I don't want that. Validity, list comprehensions, kinematic equations, bit tricks, puzzles. Want to buy 100 animals. So basically you have to query the variables after that, but okay. I remember that 3 allows to minimize some expression. Minimize. Is that about it, 3? No, I don't think so. Maximize, minimize. Okay. Parsing the tree reference. What is this? I don't know what it is, but it's just atrocious. Yeah. How do you use all of that crap? That is so unhelpful. This is OP bullshit, and its purest form. Yeah, that's pure OP bullshit. Okay, this looks a little bit more promising. Minimize. And this is a method on optimize. And optimize. Interesting. Okay, what's this? Yeah. Maybe using Rust was not a bad idea in this case, because I'm pretty sure that it's less OOP-brained and much better organized than this crap. Nevertheless, what I can do. So, my variables are these, and these are inputs. So let's say that optimization is that3 optimize. That's all. Let's say that yeah, that's not Rust. I have to use a function. Enumerate masks. Then I create a variable, that3 variable, and that looks like in 3 int of I. Oh, and I do have to know all of these variables. Interesting. Let's say that 3 variables are a list, and oh yeah, let's call it vars. Var var ends. This is atrocious. Vn. Let's call it like this. Let's call this I don't know, var n. Let's say that n vars append var n. Yes. Optimization add. Which expressions do I want to assert? I want to assert that for each jolt j joltage in enumerate joltages, I want to assert an expression which looks like expression is how do I build an expression? So how do I build expressions in that suite? I seem to remember some of this. Lambdas, recursive functions, arithmetics, arrays. I don't need this. Oh wow, data types. Show me an introduction to this. Produce optimal values. Add objective function to minimize. So for each of these lines, I want to produce an expression which looks like So how is this language even represented in Z3Py? Solver. So yeah, the pattern seems to be you create a solution, you add constraints, and then you check. And solvers can be yeah, and I want to use this one. I want to add constraints. I want to minimize an expression. I can do a debug print of S expressions. I can check, right? And I can get a model for the last check which will contain optimal values. Good. Oh, so I need to do that somehow. I don't know how, but let's just write this down. So I want to minimize some target expression, which I don't know how to do yet. I don't know how to produce this constraint, but I'll figure that out later. Then I have to do opt check. And then if everything is well, consistency, produce optimal value. Oh, okay. So what did you do? Optimize, minimize, argument as And you don't know what target is. Yeah, that's expected. And also you don't know what expression is as well. Yeah, no, you should fail in here. Yeah. So yeah, now let's figure out how do we build expression of variable sizes. So when you know the number of variables, then translating that is very easy. You just write this Python DSL with plus, with comparisons, just Python objects basically, and it builds a Z3 AST under the hood. But in my case, it's not that easy. I have to figure out how to build AST dynamically. And I don't exactly understand that. That's why py build AST. Advanced topics. Expression sort and declarations. I don't care. Arrays. These are not the arrays I'm looking for. Select and store constant arrays, data types, interpreted quantifiers. I don't care about quantifiers. I don't care about formatters. Okay. Fixed points, I don't care. Basics, API, PI. That looks slightly better, but that's still not exactly what I want. What's AST map? Mapping from ASTs to ASTs. What's ASTref? So I can have an expref. Let's maybe explore these references and maybe they will allow to build an AST. Okay, let's look at this. Well. I think I'm getting the gist of it. So, at first, it's just a none. Then I iterate over mask in indexes, I guess. If the expression is known, then expression becomes n vars the variable at I, multiplied by... No, that's not how you do it. Yeah, let's get the mask as well. Let's make this enumerate masks. So, what are masks exactly? It's a bit mask. Okay, that's just an int. Okay. So, I have a copy of that int. I can do mask 0, mask 1. Okay. And I need to select the jth bit out of this mask. So basically, if mask and 1 by jth bit, and if that bit is set, then I have to add to the expression. If expression is none, then expression becomes n vars, which one? These are j's, these are ith, and 0, 0, and this is j, and but we have already selected this bit. Okay, let's take a deep breath and let's not get lost. So, which n should I select? I should select the ith variable, n variable, multiplied by nothing, because if this bit is set, then this is just either 0 or 1, and this expression checks this and builds the expression if needed. Else expression becomes expression, maybe I can do it like this, n vars I. Can I do it like this? Let's try the same logic here. What do we want to minimize? We want to minimize the sum of variables. So yeah, let's try to do it like that. That will blow up. Maybe. Maybe there is a nice trick in there. Lengths of what masks? Target is target plus n vars ith plus, well, actually variable n in n vars. I can just say that this is like this, and then I just minimize the target as expr. Model. What am I even doing? Yeah. Oh yeah, I need commas. Okay, unsupported operand types. Perfect. Oh, yeah, now I remember. Yeah, let's do it like this. 1 shifted by m. Does this look good? Yeah, let's take a look at the masks. Oh, actually I want hexadecimal form. Can I do this? Come on, Rust can do this. So could you, Python. Ah, yeah. Let's try to see. A value cannot be converted into that 3 boolean value. And this comes from this. But it's not a boolean value. Ah, yeah. I forgot one important detail. I have to say that expression should be equal to a constant which comes from so it must be equal to the voltage that I try to optimize. So yeah, this part basically. Let's try again. It tried to solve it, and here it didn't like what exactly? Parser error. I don't know. Maybe. Maybe let's do it like this, I don't know. Whew! Finally! We are getting somewhere. So, we declared our variables, 5 of them. Yeah. And 1, and 2, and 3. Yeah. Everything like this. Assertion that n0 plus n2 plus n3 should be equal to 7. Set here. Okay. Let's try to get our variables out of the model. So, how do you get values out of the model? Other examples. Model. So x is a variable. Okay, yeah. I think I know how to do that. For variable n in n vars, so if it is satisfied, then yeah, actually this is not what I want. Yeah, this is building the model, and then I just have a debug output for it. Then I try to actually run the search. Opt sat is equal to opt check, and then I'm looking at the last model that satisfies it. Okay, and then I extract the variables from that model, and the variables are assigned to values that satisfy the set of constraints and goals that I put in here in opt. Okay. Now let's get the values out of it. Can I get multiple values out of it? Do I want to? Maybe. Okay. 0. Solution model. Why did they call it model and not a solution? I don't know. Solution, and I want to extract the value assigned to this variable. And then oh, and I can even evolve things in there. Wow, what I could actually do. Where is my target? Here. This is already an AST of that 3 expression. And what I can do is I can just say result is solution eval target, and that's it. And that should produce what I want. Print okay, I don't know what does it return exactly. It's a good question. So check. Maybe there are methods. Let's check. Okay. I don't know what it's about. I really don't know. It prints set, but you cannot just compare it with set. So what does this return? It does not return a string. It returns some object which is printed to a string, but what is it? Result, maybe? Ah, check that result. I think, yeah, I think I know what it is. Yeah. Okay, so what can I do with this? Okay. Okay. Anyway, what I mean, result is 12. Result is maybe let's turn off this debugging output and yeah, that's something like that. And if is it wrapper? Wow. So example should work now. Wow. So the answer is 0 here, and the answer is incremented by is increased by the result here, and it returned in the end answer. What's wrong? Interesting. But you do know that this is an integer, right? So what's wrong? Maybe I have to do something like this. How do I convert to an integer? Okay. So ASTRF. Character R, so maybe this is one of these. Finite domain ref. Internom reference. Okay, as binary. Oh, okay. As long. Okay, why not? So this should be something like res as long, I guess. As decimal as long. I don't mind. Good. What's wrong? Do I have to int non-ref? Yeah, now type checker is satisfied. Good. 9. Oh, yeah. So if negative values are allowed, then yeah, you can do this as well. Yes, unfortunately. Yeah, let's say to optimizer then. Can you declare positive integers? I mean non-negative natural numbers. That's 3 positive natural number. Do you have to manually specify this? No? Good way. Okay. Unfortunately, yes. So that should do. What did just happen? Did I run it for... Okay. Maybe that is the answer. Let's examine it. Yeah, I still don't believe it that it is solved so quickly, so there must be some catch. I want to really know what's going on. Let's examine the outputs. Yeah, now you found the correct one. Yes. This button was pressed once, 5 times, 3 times. Okay. I think it's kind of safe to try this number. Yes! Sometimes that 3 is the answer.